Welcome back, kiddos. This is part 3 of our video lessons for Unit 3 guided notes. We're talking about bonds between atoms, basically. So before we move on to page 2, I would like to point out a couple things on this periodic table that we have sitting in front of us. And that is that we have talked about metals and nonmetals, and briefly mentioned the class of elements in between, which is metalloids. So, in general, these are non-metals. Whoops, that does not say, there we go, non-metals. The ones in between tend to be metalloids. So those are elements that have properties of metals and nonmetals. And then everything else tends to be a metal. So the majority of elements in our universe are metals. Okay, so on the next page we're getting into the difference between ionic, covalent, and metallic bonds. And I mention them here because I can point at a periodic table. So ionic bonds tend to be between a metal and a nonmetal. And the ones that we will sort of talk about mostly are between these and these over here. Excuse me. Covalent bonds tend to be simply between nonmetals, and we'll talk about why. And then metallic bonds tend to be, well, they are between metals, and they have different properties. We talk about stuff like copper and aluminum and zinc and gold and silver. So you have experience with these metals in your everyday life. Okay, so keep that in mind as we go on to the next page. Okay, 3 types of bonds. So, covalent, ionic, and metallic. We'll talk about the different properties right here. So, covalent bonds tend to be the strongest of all 3. And they happen between nonmetals. And we can be more specific and say that they're going to happen when the difference in electronegativity, and I'll talk about this more, difference in electronegativity is less than 1.7. So, electronegativity is the pull of an atom on an electron. And so I'm going to draw a little picture and draw a little picture. So let's just say, and we're not talking about specifically what these are, but if we had something like this, okay, if this had a really high electronegativity, and this had a really low electronegativity, it means that this atom would be pulling on electrons. Pull, pull, pull. Okay. And this one, because it has a low electronegativity, would be ready to donate. It's like, hey, I got an extra one. I want to get rid of it so that I can have a full shell. Here, you have it. Okay. In this type of situation, an electron is actually donated to this. So this one sort of steals the electron and gets all of them. Whereas this, so we say that this has an extra electron and this has lost an electron, and that'll be the situation where there is an ionic bond. Now, if the electronegativities were kind of the same, let's see if I can. No, that's not going to erase. So if the electronegativities were kind of the same, then we could say, well, it's not one really pulling on the other. They're both pulling with about the same amount of force on the electrons, and so what they would do is they would share. And we did a couple questions previously where they had two electrons between them, and we say, okay, that's a bond. So that would be the situation with a covalent bond, okay? The difference between electronegativity is not very large, right? It's less than 1.7, and so we say that the electrons are shared. And two shared electrons makes a bond. Okay. Ionic is sort of the opposite. So they are between a non-metal and metal, usually. The difference in electronegativity is greater than 1.7. And you may run into a situation where you do one electronegativity minus the other, it's exactly 1.7, and it could be ionic or covalent. But if the difference in electronegativity is greater than 1.7, we say the electron or electrons, electron is donated. Okay, so there's a difference, shared and donated. Donated means this gives an electron to this one, okay, and the fact that they did that kind of keeps them together. Whereas with the shared situation, the electrons sort of stay between them, they share them, and this forms a tighter bond, covalent. Okay, metallic bonds happen obviously between metal atoms. And what happens is in covalent and ionic situations, it's one specific molecule that's made. When we talk about metallic bonds happen between a bunch of atoms and they just kind of mush together and don't necessarily make one specific molecule that bonds to others. So between metal atoms, we say the we say the nuclei are tightly packed, so they're squished together. Nuclei are tightly packed, and it's just, I'm going to phrase it this way, a bunch of atoms together. So not necessarily a specific, for example, H2O. All right, this is a specific ratio. Two hydrogens bond together with one oxygen and make one water molecule. Yeah, when we're talking about copper, it's just a whole bunch of copper atoms all smushed together, not in this specific arrangement like that. So a bunch of atoms smushed together, and sort of importantly, metals are, we say they're malleable. I may have misspelled that. And malleable meaning they can bend, like you can hammer metal and it'll change shape. And we also say that the electrons are free to move. Free to move. So maybe we should have a picture of that, because this is actually really important. The conductivity, meaning electricity can flow through metals, and that is sort of central to our lives given all the electronic devices that we have. So here's a little picture of a piece of metal, and this could maybe be a wire within the iPad that you're looking at right now, or computer. Okay, so these are all metal, probably copper wiring atoms, and I'm drawing little shells for the electrons, and they're all just kind of smushed together. And what happens when the metal atoms get together like this, it's a party. We have, and so I'm going to draw a couple specific electrons. this electron is not bound tightly to this atom because it's so close to this. It could jump over here, 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 it could jump over here. And the reality is that happens, and it happens all the time. And when all of these, we have a bunch of electrons flowing, okay, electrons flowing from atom to atom, that is what, that is the passage or flow of electricity. And so you are watching this on some sort of electronic device, and this is happening all over the place, where the electrons are jumping from atom to atom to atom to atom, causing electricity to flow, enabling you to watch this and learn. Okay, almost lastly, polarity. What does it mean? So, H2O, this is a perfect example. We have oxygen, and a hydrogen atom, and a hydrogen atom. So I think we went through how this bonding, how these atoms bond together to make this molecule in the previous page. But the reality is that oxygen has more pull. So if you look at the electronegativity, I think oxygen was 3.5, and hydrogen is 2.2, okay? So this is pulling on the electrons and pulling on the electrons more. Electrons are negatively charged, so we say that this end becomes kind of negative because the electrons bunch up to that end, and this end becomes positive, okay? So electrons are pulled this way because oxygen has more pull on them as measured by electronegativity. And one end of the molecule becomes negative and one end becomes positive. And that is what is meant by polarity. So polarity is one end is more negative and one end is more positive. And so we talk about polar molecules. We also talk about polar bonds. It just means one end is more negative, one end is positive. It's not the same on both sides. Okay, so what should we be able to do? I know these are notes and we haven't practiced a lot, but in the ensuing lessons, we will be getting a greater understanding of electronegativity. Okay, so what it means and what elements will likely bond together. We learned a little bit about that. We're going to do a lot more of this, drawing Lewis dot structures for molecules. And so this is when you have, for example, a hydrogen plus an oxygen atom, how do they bond and why? Okay, and that has to do with the valence electrons and with the electronegativity of each atom. So we're getting some understanding of the elements and why they do what they do. And then lastly, determine if a bond will be ionic, covalent, or metallic. And so we talked about some basic properties, the difference in electronegativity, okay, greater than 1.7, less than 1.7. And we talked about between what types of atoms will these happen. So between metals, between nonmetals, and for ionic, between a metal and non-metal. So let's write that down. So electronegativity, just as a review. Electronegativity is a measure of the pull on electrons by atoms or elements. Draw Lewis dot structures, and so for example, the Lewis dot structure for H2O, water, would be, we have 1, 2, 3, 4, 5, 6 valence electrons for oxygen, and 1 for hydrogen, and 1 for hydrogen. These two are shared between the oxygen and hydrogen. These two are shared, so 2 electrons make a bond. And we would have 2 lone pairs and 2 bonds, and it would look like this. So the oxygen's happy. It feels like it has 1, 2, 3, 4, 5, 6, 7, 8 electrons around it, which is what it wants. And hydrogen, because they're in that very top row, okay, only have electrons in their inner shell, and so they are happy with 2. Hydrogen has 2, hydrogen has 2. So very happy. They stick together. They're forming a covalent bond, and it is a strong bond, and it's hard to break that apart. And this is the way we would draw it. These little lines indicate bonds. These little pairs of electrons indicate pairs of electrons. We call them lone pairs because they're not part of a bond. Okay, and then lastly, we could summarize here. Ionic, we're going to say the electronegativity is greater than 1.7, so the difference in electronegativity. For covalent, we will say the electronegativity is less than 1.7, so they're closer together. They share. It's not one pulling an electron away. And then metallic, they're just sort of between metals, but the important thing is that the electrons, notice how I'm abbreviating an electron, the E with a little negative sign? Yeah, this is abbreviation for electron. Electrons are free to move. And that is probably the most important property of metals as far as we are concerned.